Hi class. That last unit was a pretty long one, taking a look at measures of dispersion, and in particular we were talking about how to calculate a standard deviation for ungrouped data. So now what we want to do is to take a look at calculating the standard deviation for grouped data. And this formula, or this set of formulas, are kind of ugly looking in nature, but once we've gone through them a couple of times, I think you'll feel fairly comfortable with them. So what we're doing here is, if you take a look at the original formula that we had here, which I'm going to just write out here, for calculating a population variance, and this is for the ungrouped data, this is what the thing looked like. And so what we had here then was we had the x's, and we, with ungrouped data, of course, you see all of the numbers. Like we saw the ages of the 8 kids in family X and the ages of the 8 kids in family Y, and so on. And then what we did was we came up with the deviations and we squared them and we divided through by n. And there was the computational equivalent formulas for that. What we're doing now, though, is when we're talking about group data, and again, think back to the table that we had of all of the ages of people in Red Deer. What we've got is the age classes, 0 to 4, and then 5 to 9, and so on like that. And we've got the frequency, the number of kids in each class, or number of people in each class as they get older. And then we could come up with a class mark, typically just the midpoint of the class, and we could calculate a grouped mean. And then we're going to use that method then to actually calculate then the standard deviation of group data. So instead of having x's, what we have here is we have class marks, usually just midpoints, and we have frequencies. It looks like this. One thing I want you to notice is that the frequency is not squared. That's really important when we get to the actual formula here. And then when we're dealing with sample data, it's the same thing here, is that we've got, instead of x's, we've got m's and f's, and of course instead of having mu's, we have x bars, and then we've got n minus 1 down here instead of big N. And so that gives us s squared. And the computational equivalents are down here. So let's work through that then. I'm going to go through number 45, and then we'll actually take up number 46 then in class. So calculate the variance and the standard deviation for the group data of the ages of the 50 people. Consider the data to be population data. Does the group standard deviation differ from the standard deviation that calculated before? And so what I'm going to do is I'm going to take a look here then at an Excel spreadsheet. Now remember, this is actually in the supplementary files, and so you can find this in that folder there. So let's take a look here at the ages of the 50 people up at the top here. And what we do for each class is we come up with a class mark and then a frequency. And so those two are given to us. And then we would multiply each of them together to get an MF. And then we're going to do that for each class all the way down. Right? So down here, for instance, for the 50s, the midpoint is 54.5. There were 7 50s. And then multiply those together and you get 381.5. So I'm dealing with the original 50 ages of 50 people, the data that we've been using right through units G and C. And we add all of those up and we end up with 3495. We divide that through by 50, and we get 69.9. So that's what we've got there. Now, by the way, we saw that back on, I think it was about page C7. So let's just go back there. Page C7, which is, where would I find that? I'm going to say it's about page 69 here. There it is. So that's what we did. So that's where we came up with this mean here then of 69.9. So you can go back and take a look at that on page C7. Now, by the way, we did this for the marks of 50 students as well. I've actually got that in the table. But we're considering them to be population data. We use exactly the same method for calculating the mean if it's sample data, so it's not going to make any difference when we take a look at handling these as sample data. But let's continue on here then. So what we've done here then is we've taken a look at the first three columns here then. So you first have to come up with the MF column, which is used to sum up, divide through by n to get your mean, which is 69.9. And then we could come over here and we could take each m, its class mark, again usually just a midpoint, minus the mean, so 4.5 minus 69.9, and then multiply by that by the frequency. Well, that's just 0 in the first case. That's kind of boring. But the next one here then is 14.5 minus 69.9, and then multiply by 1 gives you a deviation of 55.40. And you could do that for each one and add them all up, and you'll end up with 0. And that's the way it always turns out, because that's just exactly the same as that column that we did with family X and family Y, where we averaged out the deviations from the means. And of course, remember, the mean is the arithmetic center point of the data. And so all of the positive deviations will cancel out all the negative deviations. And so this column will always sum up to 0. Take a look at the other examples that I have down here. 0, 0. So you would never actually use this particular column here. You don't do that. This is just for instructional purposes. You'd use one of the latter two columns, so column G or column H here. And for computational reasons, you'll find that H is actually a lot easier. But let's walk through column G first. So what we do is, and I'm going to go down a little further down here, maybe to the 50s. So I'll look at row 9 here. So we find out a class mark, so 54.5. And its frequency, which is 7. And then we multiply them together to get that. Of course, that's going to be used to calculate our mean. And then, again, we're not going to look at this column here. We've looked at column F. So over here, what we do is we take the class mark, which is 50.5, minus the mean, which is 69.9, and then you square it up here, okay? You take a look at the formula, you square it. And then you multiply by the frequency, which is 7. You don't square the frequency. You'll notice that the F is outside of the squared part. And so that's going to give you 1660.12. And you do that for each of the classes here, all the way down, and then you get this particular number here. So let's take a look at that. And so, oops, we have to go back to the right page here. So what we did in this particular case, we're talking about this particular column down here then. And we came to a number which was 15,642. That was the sum there. And again, remember that this particular full table you can go and find in the supplementary files folder if you want to take a look at all the numbers here. I'm not going to write all the numbers in here because you've got access to those. But let's calculate then the formula here then for the standard deviation, the variance. So m minus mu squared times f over n. And so this part here then is the numerator right here. So that's what we've just calculated, is the sum of those. So that comes to 15,642 divided through by 50. Remember, it's the sum of the frequencies, 50. It's not the number of classes, it's the sum of the frequencies. And that comes to 312.94, like that. And then from there we would take the square root of that and say that the standard deviation is the square root of 312.94, and that comes to 17.69. So there you go. Now, when we calculated that earlier, 17.69, compare that to up here, 17.44. So they're really close. Obviously, if you had all the numbers in, say, an Excel column or something like that, then you would use the ungrouped data formula, because it's better because you've got all of the numbers. But if the data comes already classified, such as the ages of people in Red Deer, back in page in Unit I, then this is what you would use here, and you come up with the standard deviation. All right, I'm going to leave this one here for homework for you. No, sorry. We also want to use the computational formula for this. So the computational formula then is using this guy right here. And so what we do is we go over here and we say, okay, instead of using this column here, let's see, I think I was using the 50s, right? We're just going to use this column here, column H. And we can ignore columns F and column G. So you'll still need MF, the MF column, in order to come up with the mean here. So you need the M, the F, the MF, and then you could just jump to this guy here, which is the M squared F. And you could ignore these two columns here, F and G. All right, so let's take a look then over here. And what we do then is we take the class mark, which is 54.5, and square it. And then we multiply by 7, which is the frequency. So that's what this formula up here is saying here. So 54.5 squared times 7 is 20,791.75. And you do that for every single one, and you come up with this number down here. So 259,942.50. Let's go back here now. And so that's this guy down here. Let me change colors. And so that's going to be, what was that, 259,942.50. And so the formula then that we're going to use here that's easier computationally looks like this. Okay, so it's this guy right here. And remember, the F is not squared. That's important to note here. So that's 259,942.50. Divided that by 50 minus 69.9 squared, and we'll end up with exactly the same number here. So 312.94, 312.94. And then, of course, we could take the square root of that to get the standard deviation. All right, for homework, I want to leave you with this one here. What I want you to notice is that I've now said that I want you to use this as sample data. So we're using X bars here. Now, you'll still You won't need to do this column here, but you can try that and see if it sums up to 0. That's fine, but you will need to calculate the MF column. I'd like you to try it this way, but then I'd also like you to try it this way here. And I'll give you the answer here. What you'll get is the S squared value is going to be equal to 166.90, it looks like. Not sure about my writing there. The S value will turn out to be 12.92. All right, so that is that there. And of course you can check your answers back over here. So the marks for the 50 students, and there's your columns that you need right there. Especially E, and then G, and then H. So that's what you'll need there. All right, but please do try this here. Don't just simply jump down to the answer. Make sure that you can get the numbers for at least 1 or 2 rows, and then I'll assume that you know how to do it after that, and you can continue on. So I'm going to stop that lesson at this point. And yeah,